Okay, so paper 1, gap analysis. Describe fully the single transformation that maps P onto Q. P onto Q is that way round. Please add an arrow to your diagram. So I can see first it's the rotation, and instantly, because I've added my arrow, I can see it's anti-clockwise. I can also see it's 90 degrees. Well, this length here, this line here, is kind of the matching length to this one, and you can see that that's vertical there and that's horizontal there, so it's 90 degrees. The only thing to do is to find your centre. I don't have any tracing paper on me right now, but what we do is we trace over P and have our tracing paper basically across the whole thing. And you just try some numbers, try some positions. So you might try the origin first, give it a 12, see if it ends up in the same place. Try somewhere else. 9 times out of 10, it's going to be hovering around here somewhere. On this one, it's at -2, -1. Okay. Enlarge the triangle, scale factor of 1/2. So everything is going to be half the size. So I'm just going to look at this. I can see that this is 4 by 4, so I'm going to make a triangle that is 2 by 2. It says the centre is at -5, -1, which is here. Okay, I would use a ruler. Glad I have one on me right now. What I always do when I'm doing anything to do with enlargement is I get my ruler and I go like this. So it's like imagining that we've got a torch at this centre of enlargement and we're shining it on this object. And either the shadow is going to appear over here if we're making it bigger, or it's like we've got the object in here somewhere and that is the shadow. And what I would now do is some counting. So from the centre of enlargement to this point here is across 1, 2, 3, 4, 5, 6, 7, 8, up 1, 2, 3, 4. So across 8, up 4. I am now going to do half that. So I'm going to go across 1, 2, 3, 4 and up 1, 2. So that's my first point. I'm going to tick it off. Now I know that my triangle I need to draw, as I said, is going to be 2 by 2. So 2 along the base, 2 up. I'm just going to check it with another point. So to get from here to here is across 8, up 4, 8. So now I'm going to go across 4, up 4, put your point here. And look, it sits nice and neatly in here. And if you notice, where I've drawn my ray lines, it's passing through these points. So that is my new triangle. Okay, question 10. T is inversely proportional to W. Pause. T is inversely proportional to W. So that means T equals K over W. Tick it off. W is directly proportional to the cube root of D. W directly proportional to the cube root of D. Always the order it is in the sentence. That's W equals, and I can't use K, I'm going to use a different letter. Let's just use C. Cube root of D. Tick it off. When W equals 9, T equals 10. So 10 equals K over 9, and before I carry on I'm going to finish this off. I can do something with this. I can work out that K is 90. I'm going to take that number, I'm going to put it back in here, and I've got T equals 90 over W. That is now my formula that I can use. Tick it off. Next bit of information. When W equals 1, D equals 64. 1 equals C times, cube root of 64 is 4, so C equals 1 divided by 4. I'm going to take that, I'm going to put it back in here, so I get W equals 1/4 times cube root of D. You might also write that, if you wish, as cube root of D divided by 4. It means the same thing. Finding 1/4 of something is the same as dividing it by 4, and I'm going to tick that off. Find the value of D when T is 36, so substitute this in first. The only place this can go in, I should put this in a little bubble, only place this can go in is here. So 36 equals 90 over W. I need to rearrange this. I'm going to times 3 by W first, and then I'm going to divide. Before I do anything else with this, I'm going to cancel it down. It's non-calculator, so let's make our lives a little bit easier. Both of these are definitely divisible by 9, so I'm just going to start with that. If I divide this by 9, I'm going to get 10. If I divide this by 9, I'm going to get 4. So now I've got 10 over 4, and that's both divisible by 2. So I've got 5 over 2. So W equals 5 over 2. Not quite finished though, am I? I need to take this and put it into here. It says find the value of D. So when you find the value of D, I need to take W and put it in. So I've got 5 over 2 is equal to the cube root of D over 4. So I need to multiply through by 4. So 5 times 4 is, I'm going to write it out there, 5 over 2 times 4 is cube root of D. Times 4, I'm going to make my life a bit easier. Cross cancel, 1 and 2. So I get 10 is the cube root of D. That means D is going to be the cube of 10. So D equals 1000. Question 11. The graph shows the velocity of a particle t seconds after it starts to move. Work out an estimate of the gradient of the graph at. This at means we're going to use tangent. At t equals 3. We're doing gradient. So when t equals 3, get your ruler. Try and get it so that it's roughly sort of equal amounts each side. And then we're going to do a nice gradient. So for me, that is a rise of 30 and a run of 6. So my gradient is going to be rise over run. It's gone up, so it's definitely positive, well that is 5. Velocity time, if you do velocity divided by time, which is what we've just done, change in velocity divided by change in time, we're talking about acceleration. Work out an estimate of the distance the particle travels. Distance means area under the graph. Distance it travelled in the first 6 seconds using 3 equal strips. So there's my 6 seconds. 3 equal strips are going to be down here and down here. That first one, I'm going to label them shape A, B and C. Shape A is a triangle. A half, remember it's an estimate because we're estimating and we're sort of doing this for our value. It's a half times the base times the height. So reading off there, that is about 38 on mine. B, that is now a trapezium. Half the sum of the parallel sides. Here are my parallel sides. I have to say my printout is not very good. Half 38 plus 46 times the distance between them. Distance between them is 2. Shape C is a half. Well, I know that that's 46, I've just done that. Plus 52, times the distance between them, which is 2. Well, half of 2 is 1, so that is 38. A half times 2 is 1, so I've only got to add these two. So what's that? 78, 84. Half of 2 is 1, so I've only got to add them again. So that's 40, 96, 98. And then I need to add these 3 together. And again, in the interest of time and accuracy, I'm going to cheat. 38 plus 84 plus 98 is 220. Okay, question 12. Rationalise the denominator. Every time when it's this nice basic question, we're just going to times by whatever's on the root here, so root 5 over root 5. That's the equivalent of multiplying through by 1, we're just changing what it looks like. So we've got 45 root 5. Root 5 times root 5 is root 25. Well, the square root of 25 is 5. And now, lots of people in the exam just left it like this. You need to make sure you cancel down. 45 divided by 5 is 9. So it's 9. So it's just 9 root 5. Question 13. Instantly, I can see we've got recurring decimals. So x equals 0.4 recurring, so we write it out like this. Before I do anything else, I'm going to convert this to a fraction. So there's one number recurring in the pattern. I try and be really disciplined, and I'm going to keep everything nice and neatly lined up. So I'm going to times it by 10. So I've got 4.4444. So every number is just shifted across one place. I'm going to subtract, so I'm going to subtract upwards. And what I normally do is make a note to myself of where they all of the numbers start to line up, so where they're going to eliminate each other, which is going to be there. So when I take away, all of those are going to disappear. 10x minus 1x is 9x. 4 take away 0 is 4. So I've got x equals 4 ninths. I'm now going to do exactly the same thing with y. So y is 0.9545454 ... I know there are different ways of doing this. Most successful ways I've seen is to look at the number recurring in the pattern, which is 100. So I'm going which is 2, sorry. So I'm going to do 100y. Be disciplined, keep it all lined up. That is going to give me 95.45454. Find out where it lines up. It lines up there. So when I take away, I've got 99y. 95.4 minus 0.9 is 94.5. Okay, so just be careful, you've got to do 95.4 to take away that. So y equals 94.5 over 99. This is the only bit you have to change. We can't have a decimal in a fraction, so it's 945 over 990. I've used that information, so I've ticked them off. It says work out the value of x, y, so that's timesing them. You would never sit here and multiply these two numbers together as decimals. They need to be done as fractions. So now I'm going to take my values. So I've got 4 ninths times 945 over 990. And now I need to do some kind of simplification here. I'm going to start off by saying, well, I know both of those are definitely divisible by 2. So I'm going to divide that by 2. 990, I'm being cheating, is 495. 495 can't, right? I could now look to divide both these by 5 maybe, so I've got 2 ninths, or that's probably divisible by 9, isn't it? If you add the digits up, it's going to be divisible by 9. Again, I'm going to cheat. Divide by 9, that's 105, I apologise for cheating. So now I'm going to multiply across. I've got 2 times 105, which is 210, over 495. Both of these are definitely divisible by 5. So that is 42 over 99. I think that's divisible by 3, isn't it? We can keep going. Yep, so that is 14 over 33, and that's as far down as we can go. Okay, question 14. The histogram, so I'm going to pause. Frequency density is frequency divided by width. I normally write out my formula triangle. Frequency, the area represents frequency. Weights in grams of some cakes. One of these cakes is taken at random. Work out an estimate. It's not an estimate because we go, oh, I think it's about 10. It's an estimate because we don't know exact data value. For the probability the cake will have a weight between 30 and 50. Well, 30 is here and 50 is here. So what we need to know is a frequency of all of that bit. What we also need to do first is probably work out a total frequency. So this across here, remember my printout isn't very good, that across there is going to be, I said frequency density, frequency is area, frequency density times the width. That is going to be 5 times 1, so that is 5. And please write out 5 times 1 equals, in case we make an arithmetic error. This has a width of 5, 10, 15, 20, times by a height of 3, so that is 60. So that represents 60 people. Cakes, whatever it is. This is 15 times 7. So the whole area is 15 times 7, 7 times that. That's 105, I think. Let me double check, don't want to make a mistake. Yes, 105. And then we've got 20 times 4 which is 80. So my total number of cakes is going to be 105 plus 80 plus 60 plus 5. Which is 250 cakes. That's my total number of cakes. I want to know how many are sitting in this section here now. Then I need to do it separately. That's 10 times 7, so that's 70. 10 times 7, 70. And that is 10 times 4, so that's 40. So my cakes between 30 and 50 is 70 plus 40, which is 110. So now my probability is 110 divided by 250. And just leave it like that, you don't need to start cancelling anything down.